Welcome and thank you for joining us. In today's event, we'll explore the making of advanced engines that power our economy from concept to customer. We're excited to explore this important topic with you, and we brought together an outstanding group of experts to help us do just that. A few quick housekeeping notes before we begin. All attendees are in a listen-only mode. If you have any questions, please submit them anytime using the Q&A button at the bottom of your screen. We'll do our best to answer as many as we can during this session. Please also note that today's webinar is being recorded. Both the recording and the presentation slides will be available on the Engine Technology Forum's website shortly after the event. Now I'm pleased to introduce our first speaker, Alan Schaefer, Executive Director of the Engine Technology Forum. Alan?
Thanks very much, Josie, and welcome. Good afternoon, everyone. Nice to have you with us today. We appreciate the chance to share the next hour with you. A quick word about us. The Engine Technology Forum is an educational organization that makes itself about education, outreach, and collaboration with a range of stakeholders. And of course, we're here today to talk about advanced engine technology and appreciate your attention with us. Membership in the Engine Technology Forum is these companies here, and we are delighted to have three of them represent us here today on this session. And just a few opening remarks from me. I think everyone is familiar with the important role that advanced engine technology plays across the many sectors of our economy, from our personal vehicles through the heaviest sectors of the economy for trucking and marine activities, industrial and power generation. Advanced internal combustion engines really are the main power behind our economy today. As we see our energy future shaping up, they will continue to be that, but also be working with other technologies and fuels. And we'll get into some of that today here as well. As we see it, advanced engines and renewable fuels are a sustainable solution for power and mobility, really for five basic reasons. First, the challenges facing our economy and society today are quite complex, and there's not a single solution. Our sustainable, reduced carbon future depends on a world where zero emissions technologies and internal combustion engines coexist and compete with each other to make the best possible outcome for the customers, for the users. Continuing advancements in these engines will further improve efficiency and lower emissions, both in the on and off-road space. And we see the growing success in the use of renewable fuels like renewable diesel and biodiesel and renewable natural gas is going to continue to accelerate and expand. And finally, new internal combustion engine designs and fuels like hydrogen, for example, and e-fuels are also likely to become players in the future. All these things together contributing to a continued bright outlook for advanced engine technology. And today we've assembled a group of experts here to talk about what does it take to deliver today's advanced engine and components, from research to concept, design, production, and beyond. And this is seems like a very basic concept, very basic point of discussion, but it's one of fascination, honestly, that to see what goes into producing these incredible machines that deliver so much to us. Without any further ado, we have our speakers for today, and I'll introduce each of them as they take their turn with the presentation. And first up is Steve Prowse. Steve is the Executive Director of Sales and Strategy at Tenneco Powertrain, and Steve has over 30 years experience in the internal combustion engine industry. His career spans OEM and Tier 1 engine component research and design, global manufacturing, account sales, and establishing Tier 1 startup joint ventures. He's also in leadership roles in China for 10 years. So, Steve, we're going to welcome you, and please take it away.
Thank you, Alan. Thank you to the ETF for the opportunity to speak. Greetings to everybody online. I look forward to providing insights into what a Tier 1 does to contribute into the advanced engine industry. Next slide, please. We'll start with the overview of Tenneco. Tenneco is a leading Tier 1 supplier with global reach and a portfolio of 30-plus renowned brands. The global footprint spans 184 manufacturing locations with support facilities that go across 28 countries, 60,000 employees. We play a unique role in the value chain. We work directly with the OEMs in the design, manufacture, and distribution of our products across a diverse portfolio that I'll explain. We are a private company. We were acquired by Apollo Global Management in November of 2022. Next slide. So the bubble map, the global reach of Tenneco, the local expertise, and what that does for meeting customer demands. Now, the dimension in the bubble map is the total number of locations and facilities in each region. So it's fairly balanced. You've got Europe there at the top, Germany, plus everything else, China, United States, followed by India and Mexico. Next slide. A diverse portfolio of OE and aftermarket. The OE piece of this is split primarily ICE, and the ICE components are from left to right, our clean air emissions group, powertrain that I'm representing today, and then Champion on ignition. We also hold assets in the vehicle and chassis side and what's called performance solutions, and there's aftermarket in the middle. Now, on the powertrain, what I'm going to talk about today are the base engine, lubricated, reciprocating components, pistons, piston rings, bearings, valves, seats and guides, seals, and gaskets. Next slide. So who's the powertrain business group? That business group has 4 segments. There's the light vehicle, small engine, commercial truck, off-highway, the power generation, and the rail and marine. Next slide. The mission and vision. How are we guided? The mission is fairly clear, and I think this was already mentioned in one of the previous, the overview of the company. Cleaner, more efficient, sustainable solutions. But what's interesting is the insight we can give you now into the vision, and we're focused on the commercial truck off-highway markets, while strengthening our strong positions in light vehicle. Clearly a result of electrification, so we're focused on that hard to electrify sectors and segments in what we call CTOH, commercial truck off-highway. Next slide. Some more insight into Tenneco and into powertrain. Yes to ICE. It's our identity. It's a emission badge. And I'll give you a backstory to this. This was put together, rolled out in 2021. And at the time, and prior to that, it was last man standing, and that didn't work very well. And leadership quickly realized, hey, this is not a legacy technology. ICE is a technology that's driving or working towards solutions. So we came out with Yes to ICE, and it was provocative. We would go into customers in 2022, 23, and they would say, where are you at, guys? We said, we're committed to ICE. And that's who we are. And then in 24, things started to turn around, and this seems to fit a lot better now in 25. So this is our mission badge. Next slide. So before we start talking about design, let's set it up with the market drivers and the products that shape the ICE innovation. So the Venn diagram here, it shows the complexity in the overlapping drivers, that the challenges that our products, which go around here, that I introduced earlier, are having to fit into these drivers and efficiency, durability, sustainability, and emissions. Next slide. So if we unpack the drivers, we end up with an engine development roadmap. We have the sustainability down through emissions. And to meet these drivers, we need solutions. And those solutions are described here as the Tenneco enabling technologies. And we group it 2 ways. We have the product technologies, those enabling solutions in materials, surface coatings, design innovations, but also the methodologies that it takes to bring this to market. So aligning market needs with engineering solutions. And I included some history there to show, from 2000 to 2020, the success in industry, data from EPA and DOE in these improvements in efficiency and fuel economy, CO2, and critical emissions. Quite remarkable. Next slide. So the design process for engine components with Tenneco powertrain, it's not a linear process. It's an iterative loop, driven by the marketplace and the OEM requirements. We call it holistic, and it's really grounded, or the foundation of this is our analysis capabilities. And we call that out here with analysis tools. They close the loop between design, testing, manufacturing, and real world use. Next slide. So what is the value with the design? Analysis-led design to right first-time validation. I think in essence, it's simply, cost, quality, delivery, and innovation. That's at a high level, that's what it does. But we break it down here, and the focus on the analysis-led design within our holistic process, it's optimizing performance of the products, which allows us to pull ahead the process with the OEMs. Pull ahead, they can avoid costly engine testing and time. Part of this is the in-house software development that goes with this. This is something we started when I joined in 1998. This goes back into the early 1990s when some of these tools were started, and it's provided a lot of benefit going forward. And one example would be if we look at next generation alternative fuels and what we're doing in that space right now, having this in-house developed simulation capabilities, CAE tools, has allowed us to innovate quicker and to move through that in a better way. It's also applied to manufacturing, and you can see in the diagrams what we're meaning here are the examples from thermal analysis and the mechanical thermal to component dynamic simulation, real world simulation, and then manufacturing, whether it's metal forming or friction welding. These tools are applied on the product and on the process side. Next slide. So it takes infrastructure to do this, and this is the third pillar of that holistic loop, which is testing. And this shows the global picture of the technology network of Tenneco powertrain. Down on the bottom are the test locations. There's 4. There's 2 in Plymouth, Michigan, where I'm at now. I'm speaking from Plymouth in the technical center. 2 in Germany, in Burscheid and Nuremberg, and then in Shanghai, China. And these engine test facilities cover the light vehicle and the heavy duty markets. Starting in 2022, we brought hydrogen testing into Germany, and then in 24, we launched the hydrogen capability in the United States. Up above are the product-specific technical centers around the world. Next slide. Manufacturing. Tenneco's powertrain portfolio contains complex materials and processes. We have a lot of high-speed machining. We demand continuous improvement approaches, whether it's the more traditional simplification and process flow and traditional automation to address labor cost in these areas, but also into the more advanced side on what we call smart manufacturing and digitalization, where we can take in real time, read data off a process and react to it. And this is becoming more important. Next slide. So in closing, we're excited about the future of ICE. Now, ICE remains a viable propulsion option with potential to increase, particularly in what I mentioned earlier, the hard to electrify sectors, that heavy duty area, on highway, off highway. And the OEMs are doing a lot of diversification. There's a range of alternative fuels and low carbon options and even zero carbon hydrogen. And also on the electrification side, where we got hybrid and range extenders. So that's exciting. Engineering excellence and components will continue to drive ICE advancements. And the prioritization for us in powertrain engineering is to look at these OEM drivers in the diversification, and we look at alternative fuels. We have to still maintain that efficiency and fuel economy and bring those analysis tools to bear for that. At the same time, preserving cost competitiveness that's becoming more challenging and our supply chain resilience. So thank you, Alan, for the opportunity to present. That's the closing slide.
Great. Thank you very much, Steve, for that great presentation to kick us off. We've got the leading component supplier. Now we're going to hear from a leading engine manufacturer, and I want to welcome Iman Yadehi from Cummins to stage here. Let me get that along. Just a quick reminder, submit your questions in the Q&A box. We'll get to those at the end. Iman is the General Manager of Alternative Fuels and Fuel Delivery Systems at Cummins. And Iman, welcome, and thank you for being with us today, and take it away.
Thank you, Alan. Just let's park on this slide for a second. Good afternoon for our North America audience, and I would say good day to all, depending on where you are in the world. So as Alan mentioned, I am Iman Yadehi. I'm here representing Cummins. In relation to the topic of the day, the making of the advanced engines that power our economy, my tribute, so to speak, is to discuss the manufacturing of Cummins hydrogen internal combustion engine. So Alan, let's transition to the next slide, please. I am proud to serve in a company, Cummins, with the values and longevity that we have. So our journey to power a more prosperous world has seen us across 100 years in business, and we effect change globally through just under 70,000 employees located in about 190 countries and territories. We also do it in partnership with about 19,000 Cummins certified dealer locations. So together with this excellent group and in partnership with our stakeholders, we power solutions that drive global economies daily. May I have the next slide, please? Now, I'm going to let you in on a secret, and it's one of the worst kept secrets about Cummins. We have a rich history in diesel engines. It's what we have done in the past. That said, now we've evolved in our service to our customers and communities by becoming more of a power solutions provider to commercial, industrial, and several other applications globally. We strive to be there for our customers today, tomorrow, and we do this by driving innovations towards a cleaner environment. And honestly, to me, that is the core message behind our Destination Zero strategy. We have a responsibility, everyone on this call. We have to play our part to decarbonize our industry, which contributes in its own way to CO2. And it's not something we can do on our own. And the responsibility requires action today, and it requires partnerships, and it requires awareness. And the awareness is such of this quality that has been provided by the Engine Technology Forum, which, again, thank you for this. We leverage multiple fuel sources to deliver a wide range of alternative power solutions to our customers, everything from advanced diesel through BEV, fuel cell, and again, the topic of the season, why we're here, the hydrogen internal combustion engine. Next slide, please. So if you recall from maybe a couple of slides back, you remember we invested, I think it was 1.4 billion in 2024 in R&D, research and development. So in case you're wondering, our commitment is clear to evolve our power solutions. To that end, in the hydrogen space, we're not only working on H2ICE. Via our Accelera by Cummins business, we also have presence in hydrogen production and fuel cells. And through our joint venture, NPROX, we have presence in the hydrogen storage solutions side of things. May I have the next slide, please? So everyone loves a cool acronym, so do we. Cummins HELM. HELM stands for higher efficiency, lower emissions, multiple fuels. I'm excited for this. This is our new approach to platform development. We're looking at commonizing infrastructure and components below the cylinder head across diesel, natural gas, and the hydrogen engines. By doing this, we're able to really leverage our technical expertise, our manufacturing excellence, our existing supply base reach to rapidly bring solutions to life for our customers. So I'm gonna land the plane on this one real fast. A key goal here, importantly, is to give our customers the power of choice. We want to put our customers, several of whom I expect to be on this call, in control of the path they choose to take in their decarbonization journey. Next slide, please. So I previously shared that little secret with you, deep history with diesel engines. And if you look on the far right, that serves as the base of the bridge of our various technology pieces. The other two that are represented here are hydrogen internal combustion engine and fuel cell in order from left to right. So diesel is one of several pieces that has paved the way for hydrogen internal combustion engine. And that H2 ICE will provide an engine that gives just familiarity to our customers and technicians alike, that common chassis, componentry, service infrastructure, the things they know and love so much about the Cummins engines. Now, the hydrogen internal combustion engine in turn will aid with the transition to hydrogen fuel cell, looking at things like leveraging similar fuel storage solutions, as well as influencing pricing, fuel pricing, and service infrastructure readiness. And I want to give a small call at the bottom of the screen. You see a relationship with natural gas on the service infrastructure readiness side of things. When you look at safety needs, such as infrastructure for leak detection and bay doors, et cetera, et cetera. May I have the next slide, please? So at Cummins, we're really investing in various zero carbon options. And we do that to meet our customers where they are and where they need. We are receiving interest, a lot of interest in our H2ICE technology, just due to the commonality with existing powertrains, amongst other things, a few of which I mentioned in the last slide. Now, that said, there is a lot of uncertainty in the space today, be it in North America, be it globally. We all face these uncertainties. Be policy, could be infrastructure, could be fuel price, you name, insert here. But I believe together as industry, we can send a signal to highlight the required changes that we need to support what we consider this H2ICE as a very practical technology of the future and of now. Alan, next slide, please. So this slide just double clicks a little bit into two engines we're currently working on in this space, the 6.7 liter and the 15 liter. I would say if there's an application that tickles your fancy you don't see here for future purposes, does not mean it may not be a viable option in the future. I'm just putting the two that are in development right now. Both have power and torque that are not too dissimilar from diesel, as you can see on the specs. And we plan to certify to the various standards from Euro 7 to the Tier 4 final. From an architecture standpoint, the architecture on the engines, you see they have the pent roof, cylinder heads, the tumble combustion with direct inject, and that lean burn, which gives it that nice diesel-like feel when in operation and in performance as well. I have the next slide, please. So I'm going to share just a few snippets now on some learnings from our production in Jamshedpur in India. But before I start, I would like to just highlight our OEM partner in India, Tata Motor Limited, for being with us on this journey that we've taken on there specific to, and in this case, this particular engine. Together, we have leveraged Cummins' footprint, Cummins' expertise in India to support that Make in India initiative, focusing on continuing the growth of that market as a leading design and manufacturing hub. So our 6.7 engine, I'm excited to say, is in an advanced development stage. In fact, there was a press release, I think in March, about a unit we have operational in India and continue to move on with prototype production there. I would say thanks to the architectural design, it really has demonstrated that diesel-like performance ratings. And again, in addition to the Cummins Helm approach, it sees us future-proof for overall market applicability of this engine. Alan, the next slide, please. And I believe this might be my last one. Without giving away the family secrets here, I gave you one earlier, that's enough. I would say the learnings are similar to any new product design with the added complexity of designing for new fuel, need for scale, you name it. We have similar complexity as most of our partners and other OEMs and engine manufacturers do. I would say the same supply chain and manufacturing growth opportunities apply. But again, this is where our approach with Helm and with that common architecture is proven invaluable to get us to scale rapidly and get the customers what they need. So I'll wrap up here. In conclusion, I would say we are super excited about supporting our customers, our stakeholders in their decarbonization journey, with this hydrogen internal combustion engine being a piece in our overall portfolio. Thank you.
Thank you very much, Yvonne. That was great. Great to hear the good work going on with hydrogen internal combustion engines. Okay, our final speaker for today's session is Nicholas Soderstrom, and Nicholas is the Director of Engineering and Powertrain Production for Volvo Group. And I'm going to turn it over to you, Nicholas. Welcome. Thank you for being with us.
Thank you. I can just switch to the next one, I guess. This is just short about me, and I'm Nicholas Söderström. Yes, I'm originally Swedish, but right now I'm then the Director for Industrial Engineering here in the Volvo Hagerstown site. I've been with the group for more than 20 years, all of them in engineering, different areas around, and both for vehicle and powertrain. So that's a little bit short about me. Next slide. So Volvo Group, yes, we do trucks, buses, marine drives, power generators, construction equipment all around the globe. As you can see, we are roughly 100,000 people now. And what we don't do is Volvo cars. That is in another business unit. So we focus on more the industrial scope then. And our presence is more or less all around the world. So if you go to the next one. Here's just a bit on what we do here, and you can see we are then slightly more than 2,000 people here around in the Maryland area, and we are still investing pretty heavy in all of these areas that what we do here when it comes to driveline components. Hagerstown is neatly located, you can say, in between our two vehicle plants, one in Lee Valley where they do Mack trucks, and then one in New River Valley where we do the Volvo trucks, and then we also have Prevost, the bus brand up in Canada. So we are in here supplying the different vehicle areas with their driveline components. Of course, sustainability is a big portion of what Volvo does, so we are also doing things here to try to reduce our footprint. We are working a lot on different development as well, and right now then we are moving into more in that area. If you go to the next slide. This is a bit of a unique facility in the group. Hagerstown, we have a building here that's slightly over 1 million square feet, I guess. But it contains both the technology development design team, we have purchasing team here, and then we have an operations team. We have variation types of labs, we have quality labs, we have cleanliness labs, and the technology team has just more or less opened a vehicle propulsion lab where we can also then do more testing on different environments and temperatures and so on, so we can do a full driveline test. We have all the things we need for operations and like occupational health, family center for doctors for all our employees, gym, and so on. And then you can see some of our solar panel roofs there on the parking lot. So yes, this is where we are located today. Next slide. So a bit of a journey here. Mack trucks, this was originally started in the 60s when they moved down. In somewhere in the 90s, they were part of a purchase from Renault Trucks, and then roughly 10 years later or so, AB Volvo purchased Renault, and Mack became part of the Volvo Group. We started producing our Volvo engines here in 2004, and then we have been transforming and adding on products ever since. So we are very much still investing here and in these products for the North American and market overall, both in operations and engineering and infrastructure around us. If we move forward. So here in Hagerstown, we produce axles, we do 11-liter engines, we do 13-liter engines, we do transmissions, and we have also done some electromobility units. We also do components for like crankshafts, camshafts. We do for axles, and we do gears and shaft for the transmissions area. So we do a little bit of everything you need to produce these driveline things. If you take next slide. So I'm going to talk a little bit about the process here, then how we get from some sort of early phase into a product that goes into our vehicles at the end of the day. So it kind of all starts with our product plan. That one stretches far out in time. And once we hit sort of a project initiation area, we kick off this process you see on the slide here. This is, of course, a cross-functional way of working with all the different functions and how we develop these things. It's also roughly something like a 4-year process for us right now. We go a little bit up and down in time, but there's always advanced technology development ongoing. So we have things ready, sort of off the shelf. So when we look at the requirement for the initiation milestones, we know what we pick of our advanced technologies, and we put them into these kind of first concept selections that we is more on the sketch stage here. We do, as you can imagine, then a lot of virtual work nowadays to speed up this process as much as possible, but also to have as much validation or testing done before we start getting into hard components. We follow for North America a pattern where we introduce something major more or less every 3 years. Lately, we have been a little bit more frequent delivering new products out because of the different legislation that come out, both for EPA, but then also for the CARB. So right now we are also then adding on a lot of these components for our new truck ranges that were just launched both for Mack and for Volvo. So now, right now, we're focusing on the next big legislation update, which is in the 2027 EPA legislation. Of course, there's been a lot of focus from our end on the fuel economy. We know we need to get our total cost of ownership in the correct way for our customers. We are working much more nowadays with a fully connected driveline, so we can improve both drivability and maintainability for our customers. This means that we have features like transmission that knows where the map is, so they know the road, they know the hills up and down, so we can keep our engines running in the sweet spot of the different RPMs, and by that, better drive, lower fuel, lower noise, and so on. So this is where our product keeps going, more and more integrations between different components. We, of course, also have a fancy name. We call it CAST. This is what we use in the group. We call it Common Architecture and Shared Technology Platforms. So we try to do, as you can see on the picture here, then the base engines is common, and we can instead add on the different regional application work done in the different areas around the world, so that we are more directly connected to the local demands. So for US here, we can do what our customers need based on the applications they have, the environment, our unique legal demands, and so on. And as in the process here shows, I mean, we try to produce some early components. We do these prototypes to verify our virtual work has been done and all the systems is working. And then we have to build for certification. And especially here in North America, this is a big of that process step is pretty big, because there's a lot of long-term testing to prove to the agencies and to our customers that the things that we develop and will later on produce actually meets the lifetime targets. It leaves the maintainability, but it also then meets emission regulation all along the life cycle. We go into this validation where we do a lot of on-road testing, of course, to make sure everything is what we planned before we go final delivery, and then customer gets to pick up their trucks or buses and do their work as intended. I think throughout the years, we have seen, now the combustion engine has reached its limit, right? The thermal efficiencies can never get better. And for every project we start, we keep pushing these limits. This type of technology, we haven't really seen the end of how far this can go. There is still, every time we see new opportunities and challenges appear. As the thermal efficiency gets better, we all of a sudden start to run the engines cool, and we need to add on components to manage heat and to still when we do that, we can use those components to power other features. So for everything we do, we always continue to grow how far this type of platform can actually develop. There is, of course, also a lot of development ongoing in fuels. We talked about the normal diesel. Here in our site, we have switched from normal diesel to the HVO, the hydrogenated oil. So that's a fossil-free fuel. There is, of course, a different type of gas, biogas, and as we just heard, hydrogen. So technology development on the internal combustion engine is very high inside the group. We develop all these type of different fuel because it's very hard to predict where infrastructure and different legal implications will take us, right? And where the actual total cost will be beneficial for our customers. So we continue pushing development in all these areas to see what fits best where. And as we said, combustion engines can be fossil free. There's still a small amount of different NOx particles coming out, but who knows, with some further development, maybe we can get close to zero there as well. So from the group perspective, Volvo, we still see that internal combustion engine is a very big portion of our product strategies for years going forward. Next slide, please. And as we talked about, I mean, we do all this development, we have to use the different tools, processes, methods that's out there, trying to be better, trying to be smarter, and also then being faster so we can adapt to the different needs and the changes in the world. The more we can simulate and get some early validation of potential concepts and ideas we have, the sort of the faster we can get to the next step, producing less physical prototypes and just doing the things that's hardware where we actually get some benefit out. This is also part of the sustainability, right? We don't want to produce things that we just scrap. When we go into durabilities and we do feature validation before we can start this certification process, because once we go that route, we have to be more or less locked down on what it is we're going to produce, since that cycle is a very long one for us to meet, both for the powertrain units, but also for the complete vehicles. If you go for the next slide. So here's just some examples of things we do. I mean, we get raw material in, we machine those parts, we assemble complete products. And of course, throughout this process, we have different types of labs, in-process validations, to make sure that what we produce is according to spec and everything is clean and ready to go when we go for starting up the engines. And there is a lot of different other standards that come into for operator safeties, ergonomy, and of course, some of these stuff we are now moving ahead in this area too with automated guided vehicles and making sure we have more and more support for our operators. You can see our AGVs, right, to make sure we have good ergonomy for our operators. They have the right height, the right angles. We have electric tools everywhere to ensure that there is no noise levels that we can't manage. And of course, we connect those to our systems so we can sort of record all our torques and have good control of what quality we deliver to our customers out there. With the automation, we have to do more and more about that, both for the delivery area, but also automation in the process that further sort of drives the demand to upskill and develop our operational workforce to, in some cases, rather than maybe touching the product, they still have to help the automation run and work as intended. So there is a natural sort of progression for the workforce, also growing competence and skills along the way. Next slide, please. And this is what our end products then look like. So we get a complete unit out. If it's engines, transmissions, they all go to our different vehicle areas to be assembled in trucks and delivered to customers along the way. So that's more or less what we do here in Hagerstown, all these different things to be able to provide all of North America with the driveline components made locally. If you go to the next slide, a big portion of this is, of course, our continuous improvements or Kaizens, right? This is a picture from the Volvo Group's Operational Excellence Awards. Two of our team members won with an improvement in our transmission area. So this is a natural part of our journey here. We continuously have improvements all along our different production lines connected to how we can make the products better, how we can make them cheaper, how we can make them faster, and still deliver high, good quality all along the process. So from a group perspective, this is how we try to develop in between. And then we have more technology leaps when it comes to different things, like we just discussed some of the fuels, or if how we can integrate different things in a wider system. Or now looking forward, we have been working with Industry 4.0 for a while. I guess AI and the big data that is coming is further an enhancement that we try to put into our products to provide more value for our end customers at the end. And I think that is it for me. Thank you.
Very nice. Thank you so much, Nicholas. Excuse me. That was a great tour of the factory in Hagerstown and how things come together. It's really quite impressive when you put these three presentations together to try and understand really what goes into producing these advanced engines and technology from the very beginning to the finished product out to the customers. And I want to thank the audience for getting ahead of us and submitting a few questions. So we have plenty of time to go through those. So why don't we'll start with that. And we'll start with one of the ones that was just received, Nicholas, on your presentation. On your process side, there was a question about what is production validation? What does that mean?
So production validation for us, I mean, we have a lot of in-process validation. So like cameras, making sure we put the right components on. We have different types of validation, making sure we have no leaks. We are validating through our software controllers that all the features are there through operations, feature simulating a truck. We also do what we call a cold test. So we run the engines without any coolant, fire it up, make sure all ignition is there, all the torque is there. So that's kind of typical types of process validation we do.
Okay. Thank you very much. We'll keep you on the line here, Nicholas. Any Volvo strategies for new engine development as you consider the ICE in the future?
Yes, as we said, we're working quite a lot on the different fuels. I think that is going to be one of those where since we don't know where the world is going, this is where we spend quite a lot of our time. Combustion engine that is multi-fuel, truly multi-fuel. We want to try to maintain one common platform to both, I mean, I would say reduce cost in production, but also for all the supply base. This is, as you heard from some of the people here, pistons and so on, right? That hold the base engine unit. The more common we can make that across a multi-fuel base driveline, the better we can serve the different customer needs around, depending on what their application is, what the best type of technology is. And I think the fuel is really going to be one of those we will develop for quite some time on this type of product, in combustion engine, but also combining it with some heat modes, using some electric devices to maybe power some other features so we can control even more the fuel consumption along with the axles and the transmissions.
Excellent, thank you. Let's jump to you, Steve. Question for you. What is Tenneco's initiative towards sustainability when it comes to electric vehicles? Any plans for the future to register a footprint in EV domain other than Monroe suspension? Very specific question here.
No plans. No plans for that at all. Yes to ICE, as I showed, stays in place.
Okay.
It's a simple answer.
Thank you for that. Here's one we'll target to you, Iman, but welcome anyone's weighing in on it. Are hydrogen internal combustion engines at par with diesel on durability, just as they are on performance, specifically for fuel delivery mechanisms?
I'm just going to read that question one more time before I answer. So, hydrogen internal combustion engines at par with diesel on durability, just as they are in performance, specifically for fuel delivery systems mechanisms. So, are you talking? I guess Rakesh, I'm trying to answer this. Are you thinking range, or because if you're looking at range, then it depends on how many bars, but the cylinders you put on the equipment. But I'm trying. I need a little bit more context to give you a better answer. I want to be as specific as possible.
Good.
I don't know
Um,
if any of the other participants want to reply, Nicholas or Stephen.
I was on the same track as you. I mean, there are different tracks for hydrogen, and I mean, as you're into here, the bar and the complexity of how much pressure you need to put in for the fuel system into the cylinders. That is, of course, plus and minuses with that one. There are maybe lower pressure solutions that would be simpler to install and simpler to maintain, and probably has a long durability, but you lose some of the features of the hydrogen doing that. So I think that is a good question. I think they will see multiple hydrogen technical solutions out there depending on what this engine is going to do. I think there will be dual sparks, and there will probably be also be some sort of spark ignited versions of hydrogen just because of this durability topic.
Okay, sort of another one in the hydrogen ICE space. What's been the biggest challenge of developing hydrogen internal combustion engines for similar performance as a diesel or petrol equivalent?
So I think that's a good question. I would say what the approach we've taken with our Helm strategy, which is commonizing a lot of the componentry, really helps us provide more of a diesel-like similar performance. But that said, you gotta look at the overall ecosystem of the engine. And I think let me read this question one more time.
Sure.
Alan, which one was it again?
It's the question from what has been the biggest challenge of developing hydrogen ICE for similar performance as diesel/petrol equivalent?
Okay. So yeah, I think again the Helm strategy helps us with that. Of course, it's going to have a little bit more weight based on including the fuel delivery system on there. I think when you look at range, when you look at torque and the rest of them, we are seeing in our limited testing right now like performance, but in terms of, again, put that fuel delivery system on there, you're not going to get always the same distance as you will with a diesel engine. Now, in terms of if you're thinking about the greatest challenge for internal combustion engine in the next 5 years, I'm going to pivot this just a little bit. I think the challenge I would say is twofold. You have an economic and strategic challenge in nature. So justifying the investment in a hydrogen internal combustion engine in today's climate, when you consider things like regulatory uncertainties, amongst other factors, it's going to be a little challenging to some. There could also be, when you think about a mismatch between technology and then policy in some areas, in some parts of the world. If policy promotes one thing, then absolutely might be impact a little bit the reach or the adoption of the hydrogen internal combustion engine. Now, regardless, our goal at Cummins is to focus on the needs of our customers. We try to do that in the most economic fashion, try to provide them solutions that meet their existing asset utilization at the right time towards that decarbonization journey.
Okay, thank you for that. Let's change things up here a little bit. I wanted to, a couple of you mentioned this a little bit, but because it's all the rage now, folks are talking about artificial intelligence and how that might come into play here. How do you all see AI impacting the process of producing advanced engines? I imagine you're experiencing it at some level now, but how are you seeing that develop within your companies?
Oh, I can go here maybe. Yes, for the production process, there is quite a lot you can do with AI just to be predictive rather than so just pure like maintenance, right? We have a lot of machinery. We just talked about automation to get the machines up and running, but having the sort of an AI monitoring, making sure that we do the right maintenance and making sure we control all the parameters. There's less scrap in the process. We can have tool changes done in a way good time. But there's also the things we maybe not tapping into and using it really to drive further improvement in like cycle times and making sure everything is moving along in the most efficient way on how we actually get these products together. I think you will start to see similar things happening on the product in itself. I mean, we have all these ECUs talking all along the vehicle. It's a plenty amount of data that goes through a truck today. I think some years ago we passed the amount of code we had in a truck was more than what Microsoft had in all of their Office package some years ago, what someone mentioned. So you can imagine the potential there by having an AI-driven brain, so to say, to make the whole driveline most efficient, most serviceable. So I think there's going to be plenty of advancements thanks to AI into this type of technology.
Yeah. And Alan, I'll just add from Tenneco, similar on the business processes and then on manufacturing side where it plays a role, but we see opportunities in material science to use AI. And when we look at the alternative fuels that are in this strategic diversification, there's a lot of opportunity there. So hydrogen is one example where you can move through a lot of data with AI to look at material science decisions and strategies.
Okay, Steve, you want to weigh in on that at all? You're muted there. Okay.
No, I'm good. I mean, I pretty much align with what Nicholas and Stephen have said, and we're pretty much operating along the same lines.
Great. Okay. Let's see. We have a question. It's a hybrid technology here. Can any presenter describe manufacturer interest in hybrid internal combustion engine battery technology for the sake of fuel efficiency for types of vehicles whose duty cycles allow for that?
Yeah, I cannot. So I'll cede to Nicholas or Stephen on this one.
Okay.
So hybrid has been a whole discussion back and forth, right? You get a benefit in some areas when it comes to fuel economy if you have an electric drive and you have a battery system, but you also more or less end up with two drive lines. So here today, I mean, in the group, we have like 2 or 3 different hybrid solutions we offer. One is more like we add on generators. You have a battery and you generate extra, let's say, energy, and you have a small electric motors plugged onto your transmission that you can propel like an accelerated drive to get. Maybe you have a standard engine with a lower amount of torque or power you need, and then you can use this auxiliary engine as a boost sort of solution, right? You still need quite a lot of components around to make that work. A second solution we have is more or less when you put an electric motor in between transmission and engine, and that requires then more electricity, of course, but then you can power the vehicle fully on electricity. What we can sort of see is, depending on where legislation is going, some cities is already pushing for, if you want to go into the inner city, you have to go like electric drive. And then when you go out on the highway for regional or highway, you can go back to running on diesel or some other fuel. So there is, of course, a big benefit there, but it's very, very hard still based on all the policies around us to figure out which is the best. So I think for us, it's still going to come down to how many things do you need to pack on to your chassis or engine to make the whole system work. Batteries are still kind of expensive. You need extra generators or alternators to generate the charging systems. And then, of course, you have all the electrical controls coming back to if you want to have dual drive lines in a vehicle and still have good drivability. So there is still some challenges to have a really good heavy duty hybrid, I would say, compared to a passenger car.
Okay. Thank you for that. All right. Well, we've, I think, reached about the end of our program here. We have a number of other very technical questions. We'll see if we can't get to some of those offline. But I want to thank our presenters today for being with us. Steve, Iman, and Nicholas, great job from you all. Thank you for your contributions and helping us understand what it takes to make today's advanced engine technology. We do have a range of resources available on the Engine Technology Forum website that get into this as well. A major white paper that we produced last year is still very relevant today, give you a broad perspective on on what that looks like. From our perspective here, I think you can take away from today that these manufacturers and component suppliers, vehicle manufacturers, engine manufacturers, all are producing very advanced technology. It lasts longer, it's more efficient, it's more productive, it's lower in emissions, and they're doing that also by expanding the number of fuels and options for their customers more than ever before. So it's a lot going on. It's, I think, pretty clear as well that internal combustion engines are going to continue to be a primary source of power for many applications indefinitely, as we wait to see how other technologies fare and legislation and regulations that might drive those up or down. We have to wait and see about that, not just here in the US, but really around the globe. In the meantime, we see the opportunity for the use of renewable fuels. They offer an important, I think, and a sustainable solution for power and mobility, much more than we're using them today. Lastly, I'll just say that we see a world of technology where we have many fuels and technologies coexisting and competing, and of course, wanting to find the best solution for each need. And so that's, I think, one of the key things that was conveyed here today. So again, I want to thank our participating companies for their support, Tenco, Cummins, and Volvo Group. Appreciate it very much. And thank all of you for spending an hour of your afternoon with us. You will get a link after today's event for the recorded version of this email and slide presentations. We always welcome your feedback, so feel free to send that along to us at the email address there. We've had some other virtual events, webinars here in the recent time, and a list of those is available on our website as well. So with that, again, thank you all to our participants and our attendees today. Thank you for coming. We wish you a pleasant afternoon and a great week ahead. Thank you all.